Hi, boys and girls. This is Mrs. Roach here again for our next lesson in science. Before we get started, I want to make sure that everybody is ready for learning, that you have a quiet space, that you have a pencil to write with, and a notebook or copybook to write in if we need to take notes or answer questions in our notebooks. Okay, so once we're ready for learning, we're going to get started. All right, today I'm going to be introducing lesson 2, patterns of the moon in our solar system unit. Last week we finished up lesson 1. And so we're ready to learn more about the solar system in lesson 2. Our essential question says, what causes the repeating pattern of the moon's appearance? Okay, so this is our essential question. We will return to this question throughout the lessons, and then at the end, we'll be able to answer this with what we've learned. Okay, so here are objectives for lesson 2. I'm going to place myself up on the moon. It says, I can explain the repeating patterns of the appearance of the moon by studying its movements. I can describe the role of a stenographer and how it relates to the moon. Okay, so we're going to get started with our lesson. All right, boys and girls. All right, so you probably have noticed that the moon appears to be different shapes at night. So sometimes it looks like a full circle, other times it may look like a half circle or maybe a crescent shape. There are patterns in the way that the moon appears, boys and girls. What kinds of things can we predict using these patterns? So I'd like you to take a look at our page, Kaylee, called Patterns of the Moon on the screen. And it says there are regular repeating patterns of the moon that can be predicted. Put an X in any of the boxes that are examples of these things, of things that can be predicted by regular patterns of the moon. So first, boys and girls, I'm going to read the words or phrases in each of the boxes. And then you're going to make some predictions of which of the words in the boxes can be predicted by regular patterns, okay? And then we're going to explain our thinking on the next slide. So for right now, just listen to each word. Seasons, so we're going to look at the first column. Seasons, solar eclipses, length of shadows, position of the moon in the sky, length of a day, tides, direction of shadows, sunset, lunar eclipses, moon phases, sunrise, and weather. And so what we're going to do is, we're going to go to the next slide. You're going to explain your thinking. How did you decide which things could be predicted by regular patterns of the moon? All right, so here is the page, Keely, again. I'm going to give you a chance to look at all of the boxes and decide which ones can be predicted by regular patterns of the moon. And so you can't put an X in the boxes like the directions say, because we don't have our books with us, but you can write them down in your notebook. So anything you would put a box on, put an X on, whatever box, please just write down that word or phrase in your notebook. And then try your best to explain your thinking. How did you decide which things could be predicted by regular patterns of the moon? So please pause and do that now. Okay. So one box, this is my prediction. One box that I predict is something that can be predicted by regular patterns of the moon is the moon phases. And the reason why I would put an X on this box or write this in my notebook is because I know that when I see the moon every night, it doesn't always look the same. So I'm predicting that there is a pattern there. Okay, so your prediction, you may have selected moon phases as well and written that down in your notebook. And we will return back to this page, Keely, and see if we can add anything to our thinking, or if we have to adjust our thinking at the end of the lesson. So we will return back to this. All right. So boys and girls, here you see, I want you to look at the photos of the moon, okay, during the day and the night. This is our science and our world connection. And so the moon appears to be changing, and sometimes we can see it during the day, okay? So if you look at the picture on the left, that's the daytime photo, and sometimes you can see it during the day. So what questions you have about the moon and its phases, You're going to record these on the next slide when I say pause, but I'd like you to just observe and see if you can come up with a question based off of what you see. Okay, what do you notice? What do you wonder about in these photos? All right, I would like for you to pause and write down any questions you came up with while you were looking at the two photos of the appearance of the moon. And then you can turn back if you need to see the pictures again. So please pause and do this activity. Okay. So here is just an example of a question that you may have come up with. Why do we see different parts of the moon at different times? And so, boys and girls, we're going to be able to answer this question actually when we are done learning and when we're finished lesson 2. And any other questions that you came up with, you're more than welcome to share them with your teacher through Google Classroom. And hopefully we'll be able to answer them by the end of the lesson. Okay. All right. The next thing we're going to talk about is the career connection. And the career connection for this, boys and girls, is called a selenographer. A selenographer gathers information and data about Earth's moon to create an accurate map of the rocky surface. With these maps, future moon missions can successfully navigate the terrain. All right. So boys and girls, they create maps using data that's collected. Okay. And what they do is then when people are planning a mission to the moon, they use these maps to be able to plan the mission. And so what we're going to do now is watch kind of a cool video clip about the next mission to the moon that's being planned. And think about how a sonographer would help the next mission to the moon as you're watching this video clip. And then we're going to talk about it when it's over. So
ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man,
and left a mark in the heavens. Our successes build one upon another and amplify what is possible. It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of the giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this call. We are NASA. And after 60 years, we're just getting started.
okay. So I'd like you to just think about all that goes into the next mission to the moon, okay? And how a selenographer would help this be possible. And so, like a computer programmer, boys and girls, a selenographer analyzes data, and they analyze the data to make a map of the moon. And so you're probably thinking, Well, how do they analyze this data? And so I'm going to have you read this journal entry from a selenographer, and then we're going to answer some questions about how the data is collected. So please pause now and read these 2 paragraphs independently or out loud to yourself. Okay, I hope you got the chance to read the 2 paragraphs. We are going to we're going to answer some questions about what you read. Sorry about that. All right, so our first question says, why is an accurate map of the moon important for moon missions? So we're going to look right back in the text to find our answer. All right, so if I'm reading this first paragraph for the second time because I already read it, I'm going to look in this first paragraph in the last sentence. I could find my answer to the question. Our goal is to have a complete and accurate map of the moon's surface in order to prepare for future crewed missions to our nearest neighbor in space, which is the moon. Okay, great. So there we go. Here is our answer. An accurate map allows crew members on a moon mission to navigate the moon's surface easily and to find valuable resources such as ice. And so, boys and girls, if you read to the bottom here, sorry about that. If you read to the bottom here, they said that water can be found on the moon in the form of ice. And so that can be used for washing, for drinking, cooking. It can also be used, which I found the last sentence, which was very interesting. I'm going to get rid of that. Sorry about that, boys and girls. All right. We'll have to just work with it. Rocket fuel and renewable energy, if you could see that there. Okay. All right. The next question says, how does a selenographer make accurate maps? Well, let's return back and find out. If I reread the first paragraph here, it says, I analyze data from various lunar orbiter and rover missions to complete missions. Okay, so there's our answer in the text. And so we have both of our answers to the questions. Selenographers use data from previous missions and images from rovers and satellites to make maps of the moon. And so last week, boys and girls, we talked about rovers and how they are sent up to the moon, other planets, to collect data. And so they take pictures and things like that and send it back down to us here on Earth, which I find very interesting that this technology is available to us to be able to do these missions and then hopefully be able to do further explorations. All right, very good. So we're back to our essential question. What causes the repeating pattern of the moon's appearance? We're going to be able to answer this next week when we learn more about the moon's appearance and the moon's phases. So stay tuned. All right, some closing thoughts and questions. Does selenography interest you? Why or why not? Why would the career connection be a selenographer? What causes the repeating patterns of the moon's appearance? Which is our essential question. And so just think about those until our next lesson. Okay, here's a little science joke of the week for you. How do you know when the moon has had enough to eat? See if you can come up with that answer. And next week, I will share the answer to that joke with you. All right, boys and girls, I will see you guys next week. I'm trying to turn my camera on, but I am having no luck here. And all right. And there it is. Bye, boys and girls.